Can you believe it? Just 1 teaspoon of material from a neutron star could weigh more than the entire human population combined. Sounds unbelievable, right? But it's true. And that's only the beginning of the incredible story I'm about to tell you. Today, we're going to take a journey into the world of neutron stars, some of the most extreme and fascinating objects in the universe. First, what exactly is a neutron star? When a star more massive than our Sun, about 8 to 20 times heavier, reaches the end of its life, it explodes in a supernova. This explosion is so powerful that it can outshine an entire galaxy for a few days. But what's left behind is the collapsed core, crushed by gravity into a neutron star. Imagine this, a mass about 1.4 to 2 times that of our Sun compressed into a sphere only about the size of a city, maybe the size of Toronto or New York. It's like cramming the Sun into a ping-pong ball. That's how insanely dense it is. Here's an interesting fact. The first discovery of a neutron star happened in 1967, when Jocelyn Bell Burnell detected a repeating radio signal that blinked precisely every 1.33 seconds. At first, they even thought it might be a signal from aliens. But it turned out to be a rapidly spinning neutron star, something we now call a pulsar. Now, let's get to the jaw-dropping part, density. Just 1 teaspoon of neutron star material would weigh between 3 to 6 billion tons. The total weight of the entire human population on Earth, over 8 billion people, is only about 400 million tons. So 1 teaspoon of this stuff outweighs all of humanity thousands of times over. Let's make that more concrete. If you picked up a sugar cube-sized chunk of neutron star matter, you'd be holding the weight of 100 Mount Everests in your hand. And suppose, just suppose, you had a teaspoon of that material and dropped it on Earth, what would happen? It would punch straight through the surface, fall down to the core, and effectively destroy the entire planet like a cosmic bullet. Thankfully, there's no practical way to scoop neutron star matter, so we're safe. But why is it so dense? The answer lies in nuclear physics. When the core of the star collapses, extreme temperatures and pressures force electrons into protons, creating neutrons and neutrinos. These neutrons then get packed so tightly together that there's almost no empty space left. The result is essentially a giant atomic nucleus. To help you visualize this, if an atom is like a stadium, with its nucleus being just a tiny pea at the center, a neutron star is the opposite, an entire stadium filled wall-to-wall with peas. That's how crammed it is. And here's where things get even more fascinating. The gravity of a neutron star is so strong that, if you stood just a few meters from its surface, you'd be instantly torn apart by gravitational differences between your head and feet, a phenomenon called spaghettification. Even light can't travel in a straight line around it. It gets bent by the intense gravitational field, creating something like a gravitational lens. Some neutron stars spin incredibly fast, up to 700 times per second. They emit beams of radio waves like a cosmic lighthouse. That's what we call a pulsar. Now, here's an absolutely mind-blowing story. In 2017, 2 neutron stars collided, an event called GW170817. This collision created gravitational waves that scientists on Earth detected for the very first time. Even more astonishing, that collision produced gold, platinum, uranium, and other heavy elements. In other words, the gold ring on your finger might have come from a neutron star collision billions of years ago. A cosmic story turned into something we carry with us every day. If you're wondering, what's the connection between neutron stars and black holes? The answer is, they are like extreme cousins. If the original star was even larger, its core would collapse further and become a black hole instead. The main difference: a neutron star still has a solid surface, though it's ultra-dense. A black hole doesn't. It's a singularity with no escape, not even for light. From a teaspoon heavier than humanity, to cosmic collisions that made our jewelry, neutron stars are proof of the incredible wonders of the universe. They remind us that out there, the universe is far stranger and more fascinating than we often imagine. If you found this story interesting, don't forget to like the video, subscribe to the channel, and share it with your friends. I'm your name. See you in the next cosmic adventure.